Hi, in this segment we're going to discuss the proper installation of a oxyacetylene torch to an oxyacetylene system. In a prior segment we discussed how to attach the regulators to both the oxygen and the fuel gas. They've all been tested for leaks, set appropriately, and now we're going to attach the following equipment. First we're going to attach the oxygen hose. You want to take a look at the hose. You want to inspect it before you attach it. Make sure the connections, especially the connections around the torch and the regulator, are safe. You want to bend the hose upon itself. If you see any cracks in the outer cover of the hose, generally speaking, that hose is not safe to use. You want to do it for both hoses. Now we're going to attach the oxygen hose to the outlet. We're going to make sure that there's no pressure on the spring on either regulator. And we're going to attach the fuel gas, in this case acetylene, to the hose. And we're going to take a smooth jawed wrench and we're going to tighten both connections. Remember, acetylene turns to the left. Now we're going to look at the rest of the equipment, make sure there's no damage to the hose. The hose near the torch, make sure there's no damage to the torch itself. Everything is tight, all valves are closed, and the hose connections are tight. If the hose is not straight, I'll show you an easy method of making it straight. You don't want to attach your hose so that your torch is like this, puts undue stress on the hoses, plus it's dangerous, it might twist out of your hand. So you want to make sure that they're straight and even. Tighten them by hand and tighten them with a wrench. Again, left-handed fuel gas hose. Everything is tight and ready to go. Now, we've already tested the oxygen for leaks, and we've already pressurized the regulator at least once, so the heat of recompression phenomenon is taken care of. Now we're going to turn on the regulator again slowly. It's a good habit. And then we're going to shut it off. Now what we've done is pressurize the inlet of the regulator. Now we're going to turn the T-screw in until we get about 10 pounds on the gauge. Once we have 10 pounds on the gauge, we're going to stop, close the valve again, make sure it's closed, and observe both gauges. If there's no drop in pressure on either gauge, we know the system is gas tight through the stem, into the regulator, both gauges, through the hose, their connections, all the way to the torch, and we've even checked the valves on the torch, that they're functioning properly. We're going to turn it off again. We're going to back out on the, we're going to release the excess pressure until both needles go down to 0. Back out on the screw and get ready for setting the proper pressure. We're going to do the same pressure test on acetylene, but first we want to pressure test it with bubble solution. That's the alternative method of testing for leaks. Again, we're going to pressurize the system, shut it off, give it a little bit of gas, 10 pounds of pressure, and again take some approved bubble solution, check the inlet, the outlet, gauge connections, and hose connections at the torch, so we don't have a leak. Now we're going to shut it off again, bleed off the excess pressure until both gauges go to 0. Shut the valve off again, and back off on the screw. This may seem like it takes a lot of time, but with a little bit of practice, it's very easy and quick to do. Again, you don't have to do both. Okay, we're going to do the same thing for the fuel gas. Turn it on, put a bubble of gas into the regulator, observe no leaks. We're going to pressurize the torch system. 5 pounds is good enough for acetylene. We're going to observe There's no movement of the needle, so that means that is gas tight also. Now we're going to bleed off the excess pressure. To both needles rest on 0, close the valve again, and back out on the T-screw. Now both these regulators, the torch, the hose, the entire systems have been checked for leaks. They're safe to use. Now the next step is to set the proper pressure. And you have to check with the manufacturer of the equipment what the recommended pressures are. In this case, this is a Harris torch and tip. It's a size 2. So we know we have to put 2 pounds of pressure on both the oxygen and on the fuel gas. So again, I'm going to turn on the regulator. But this time I'm going to turn the valve all the way open. There are 2 seats on a high pressure valve. Any high pressure gas, including argon, helium, compressed air, nitrogen, all of them have a high pressure valve on them. They have 2 seats. One when you close it and the other when you open it. The one at the top of the valve keeps the gases from leaking through the valve stem as the stem wears. Now we have the valve all the way open. We're going to put the proper amount of pressure. So it's kind of difficult to read the pressure, but bring it off the needle approximately 1 or 2 pounds. So it's set about 2 pounds. Now we're going to go to the acetylene. On the acetylene valve, you don't open it all the way. What you open it is at least a half to 1 full turn. You want to make sure if you have a problem, and most incidents occur around the valve itself. You want to be able to make sure that you can turn this valve off very quickly when necessary. So from one half to 1 full turn is all you need. Now we're going to set the pressure on the acetylene, and we're going to put it on 2 pounds. Now generally speaking, we want to set the pressure at flow. This is not necessary for small tips, but for very large tips it's very critical. And what that means is once the pressure is set, you want to open up the valve slightly, and if there's any pressure drop, you want to bring it back up to where it's supposed to be, then shut it off. We'll do the same thing for the oxygen. So now both regulators are set with the proper pressure at flow. Remember, when the engineers manufacture equipment, they measure pressures for the appropriate tip at torch entry, and that's what we're doing. We're allowing you to be able to set these torches to simulate torch entry at flow. Okay, next step is probably the most critical step in the whole process. It's much more important than the proper way you attach regulators, hook up the hoses, check for leaks. And this is called purging the system. Most of the catastrophic accidents occur, and the catastrophic injuries occur when you have hose explosions. Generally speaking, torches don't normally explode, but hoses do very easily. That's called a flashback. And that occurs because the gases are mixed up into the wrong system. In other words, the fuel gas might have migrated for some reason into the oxygen hoses, or back up into the cylinders themselves, or into a pipeline, or the oxygen has reverse flowed into the acetylene system. Now to prevent this, to keep this from occurring, we have check valves. They're one-way valves. We also have flashback arresters. And Harris does encourage the use of both flashback arresters and check valves. In the event there is a failure of these type of devices, we want to make sure that we clear the system to prevent the catastrophic hose explosions. And the simplest way and very quick way of doing it is crack the valve. First I'm going to do the oxygen. You open up the valve and you let the gas flow. 5 seconds for every 10 feet of hose, or 3 seconds for every 10 feet of hose. And we close off the valve. And we open up the fuel gas valve, do the same thing. 5 seconds for every 10 feet of hose. Then close it. Now this system is pure. Pure fuel gas in the hoses, in the fuel gas hose, and pure oxygen, so you cannot have an explosion. You cannot have a flashback. And now the pressures are properly set. I'm going to show you how to light the torch and adjust the flame.